There we go. So an inscribed angle is an angle whose vertex is on a circle and the sides contain chords of the circle. Okay, again, chords are a segment that hits your circle in 2 points. So in circle G, minor arc DF, okay, is an intercepted arc. Okay, so that means that this inscribed angle intercepts that arc at points D and F. Okay, so that's your intercepted arc. Now we do have an inscribed angle theorem. So that states if an angle is inscribed in a circle, then the measure of the angle equals half the measure of the intercepted arc. So if I know that my intercepted arc, we'll say, is 30 degrees, I can find my inscribed angle. Okay, all I have to do is take half of my intercepted arc to get that inscribed angle is 15 degrees. Okay, so it's half of that intercepted arc and vice versa. If I knew that inscribed angle was 15 degrees, I can find that intercepted arc by multiplying by 2. Now that is different from your central angle. Okay, so your central angle, if I were to draw that in, okay, so that would go from point G and it would intercept that arc at D and F still. But your central angle is always going to be the same as your arc. So this angle right here that I kind of made would be 30 degrees. Okay, so your intercepted or your inscribed angle is different from your central angle. Okay, inscribed angle is half the arc. Central angle is the same as the arc. Okay, you do need to know that difference when you're doing practice problems. Okay, any questions on that so far before we do some examples? All right, so we're going to use that theorem to find each of these measures here. So number 1, we want to find the measure of arc AC. So that is this arc right here. Okay, that is your intercepted arc, and I'm given the inscribed angle. So all I have to do to find that arc is take my inscribed angle measure, which is 36, and multiply it by 2 to get that intercepted arc is 72 degrees. Okay, so if you're given that inscribed angle, multiply it by 2 to get its intercepted arc. Number 2, this time I'm trying to find angle N. Okay, it's talking about this angle L and K right here. So that one. Now I'm given my intercepted arc this time is 62 degrees. Trying to find that inscribed angle, we just do the reverse. We take that intercepted arc and we'll divide it by 2 to get our angle is 31 degrees. Okay, so you have to look for that intercepted arc, where those 2 chords hit your circle. So you'll have to follow that angle to where it hits those 2 points to create that intercepted arc. Okay, number 3, we're trying to find arc QSR. So from point Q to point S to point R. Okay, so that whole arc right there. Now if I look at my angle QPR, it hits this point Q and this point R to create that intercepted arc. So to get that arc, if I'm given the inscribed angle, I just have to take that angle measure and multiply it by 2 to get that intercepted arc measure. And that was 226 degrees. Okay, questions on your intercepted arcs or your inscribed angles and how to find them. Okay, again, your intercepted arc, you have to follow those chords to see which 2 points it hits on that circle to create that intercepted arc. All right. Next, if 2 inscribed angles intercept the same arc or congruent arcs, then the angles are congruent. Okay, I'm going to show you on the examples below what that says. So if I have this angle VTU, okay, so this angle right here, VTU, it intercepts that arc VU, right? Okay, it hits that circle at points V and point U. Okay, well then if I look at another angle here, VWU, that angle also intercepts that arc VU. Okay, so both of those angles intercept that same arc of VU. Okay, that's this arc right here. Since they both intercept that same arc, that means those angles have to be congruent to each other. Okay, so that angle W, well, VWU, and this angle VTU would both be congruent. Okay, same thing with arc WT. So if I look at arc WT, my 2 angles that intercept that arc would be WVT and WUT. So both of those angles intercept that arc, so they would have to be congruent to each other as well. So that helps us solve problems 4 and 5. So in problem number 4, we want to find the measure of angle U. Okay, angle U is right here. That's the one they're talking about. Well, since angle V and angle U are congruent, and angle V is 30 degrees, angle U is also 30 degrees. Okay, then number 5, we want to find the measure of angle T. That's this one right here. So to find that angle measure, first I have to solve for x. And I know angle W and angle T are congruent. So I can set their measures equal to each other to solve for that x value. So I have 3x plus 4 equals 2x plus 9. Okay, subtract 2x to get x plus 4 equals 9. Then I'll subtract 4 from both sides to get x is equal to 5. Now I still want to find the measure of angle T, so to find that angle measure, I will plug 5 in for x. So I have 3 times 5 plus 4. And that's 19 degrees. Okay, so again, you're looking for 2 angles that intercept the same arc, and then those 2 angles have to be congruent because they are intercepting that same arc. Okay, I want you guys to do 6 and 7. Okay, number 6 and number 7. Again, same process. Look for your 2 angles that intercept the same arc. Those 2 angles have to be congruent. All right, so number 6 wants you to find the measure of angle A. So angle A is right here. That intercepts arc BC. Okay, the other angle that intercepts arc BC is angle D. So those two angles have to be congruent to each other. So to solve for A, first I need to solve for Y. Okay, since those two angles are congruent, I can set them equal. So we have 6y minus 2 equals 5y plus 8. Okay, subtract 5y, add 2. You get y is equal to 10. Okay, so I'll plug in 10 for y. So I have 6 times 10 minus 2. That is 58 degrees. Okay, then looking for angle C. Angle C intercepts arc AD. The other angle that intercepts arc AD is angle B. So those two angles have to be congruent to each other. So first I need to solve for x, so I'll set those two equations equal. Okay, and then once I solve for x, I get x is equal to 8. And I subtract 6x and add 11 to both sides. Okay, then I can plug in 8 for x for angle C. So we have 7 times 8 minus 11. That is 45 degrees. Okay, so you want to pick out those two angles that intercept that same arc. Those two angles have to be congruent. Okay, questions on 6 or 7? All right, then moving on here. Those top two problems are using your inscribed angle and your intercepted arc. So in number 1, you want to find the measure of angle BAC. How would I do that one? You would divide it by 2. So you take this arc BC of 124 and divide it by 2 to get that angle measure of 62 degrees. Okay, then finding the measure of arc RS. RS is right here. We do have an inscribed angle, RQS, of 22 degrees. So to find that arc measure, we'll take our inscribed angle, multiply by 2. So that arc is 44 degrees. Okay, so just using your inscribed angle and your intercepted arc to find those. So again, those ones are like the ones we did on the front, those first 3 problems. Our next property we have for a circle states if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, there are some bolded words there, our vocabulary words. So a quadrilateral. How many sides does a quadrilateral have? 4. So a quadrilateral is a 4-sided polygon. Okay, the word inscribed, meaning it is inside a circle. Okay, so we have a 4-sided polygon inside a circle. We're talking about its opposite angles. So those are angles not next to. Okay, so those are angles across from each other. Angles that are not next to each other within that 4-sided polygon. And then those opposite angles are supplementary. What does supplementary mean? Adds to 180. Okay, so if we have a four-sided polygon inside of a circle, then the angles that are across from each other or not next to each other have to add to 180 degrees. Okay, that's what that property is saying. Now we'll use that not in our first two problems, but the last two problems we do. So looking at some examples, for 1 and 2, we're using this circle here. Now that is not a four-sided polygon. That is a triangle. It is three-sided. Okay, so we're not looking for opposite angles to add to 180. However, since this is a triangle, I know all three of these angles here have to add to 180, right? Okay, it's a triangle. Well, I need to find out what angle WYX is. Well, if I look at that angle, it is an inscribed angle, okay, that hits the points X and W. So it has that intercepted arc from W to X. Well, if WX is a diameter, what would that arc have to be? 180. So to find that angle measure, that inscribed angle measure, I need to take the intercepted arc of 180 and divide it by 2. Okay, that would be 90. Okay, so I have all three angles within that triangle. So all I have to do is add all three together, set it equal to 180 to solve for X. Okay, so we have X plus 12 plus X plus 90 is equal to 180. Okay, so we end up with 2X plus 102 equals 180. Subtract 102 from both sides of your equation. And then divide by 2. Okay, so that was number 1, solving for X. I got X is equal to 39. Okay, number 2, using that same picture, we want to solve for the measure of angle W. Well, angle W is X plus 12. I now know what X is, so I'll just substitute in 39 for X. So we have 39 plus 12. So the measure of angle W is equal to 51 degrees. Okay, so when you see problems like this, you do want to try and find that intercepted arc of an inscribed angle. Okay, you want to always look for those because then you can find out what that angle measure is. Just take that intercepted arc, divide it by 2. Questions on 1 or 2, how I found that angle, how I solved for X, anything like that. All right, then I want you guys to do 3 and 4. It's very similar. Do numbers 3 and 4. You just follow it forward. So it gets an R, right? And follow the other forward. Yes. So you just have to follow the chord of that angle. Okay, so for number 3, we want to solve for x. So again, I have this triangle formed inside of my circle, and I'm missing just this angle S, because I know angle R is 2x and angle T is 4x minus 6. So I want to know what this angle is so that I can add them all together and set it equal to 180. Well, I see that angle S intercepts this arc at point R and point T. Well, that arc is formed by that diameter, meaning it's 180 degrees. So to find that inscribed angle, I just take that intercepted arc, divide it by 2, and it is 90. Okay, so to solve for x then, I'm just going to take all 3 angles, so 2x plus 4x minus 6 plus 90, set it equal to 180. Okay, once you solve for x, you should get 16. Okay, you should have gotten x is equal to 16. Then, I want to find the measure of angle t, so I just need to substitute 16 in for x for that angle. So we have 4 times 16 minus 6. So the measure of angle T would be equal to 58 degrees. Okay, so that's what I would do if you're given a picture with that triangle inscribed in your circle. Find that missing angle using your intercepted arc. Questions on 3 and 4. All right, then for 5 and 6, that's where we're going to use the property that I laid out above. Okay, so again, that property says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So I do have a 4-sided figure inside of a circle. Okay, then I want to find its opposite angles. So those are angles that are across from each other. So that would be angle P and angle R, and angle Q and angle S. Okay, so those are your angles that are across from each other. Now my property says that those angles have to be supplementary. So to solve for angle R and angle S, I need to first find out what x is. Okay, so to find x, what I can do is take those opposite angles, 75 and 3x, add them together, set it equal to 180. Now, most students on problems like this will set those equal to each other. They are not equal to each other. They are supplementary. Add them together, set it equal to 180. Okay, so from here I'm just going to solve for x. So I'm going to subtract 75 from both sides to get 3x is equal to 105. Then divide by 3. And x is 35. Okay, but I didn't need to just find x, I needed to find angle R and angle S. So to find angle R, I'll just substitute 35 in for x here. So I have 3 times 35. To get the measure of angle R is equal to 105 degrees. Okay, then for angle S, again, I already have what x is, so I don't need to reset that up as 2x plus 110 equals 180. You'll get the same value for x. So I'll just substitute 35 in for x there. So I have 2 times 35. To get the measure of angle S is 70 degrees. Okay, so again, with these problems, your opposite angles add to 180. Questions on 5 or 6? All right, do problems 7 and 8. Angle, not an inscribed angle. So your inscribed angle has to be on the circle. Your central angle comes from the center. Well, yeah, so if it goes from the center, it's the same. Yeah. All right, so I want to give you some time to work on your assignment here. So I'm going to start going through 7 and 8. So for number 7, you're finding angle W. That's this one right here. So I need the angles that are opposite each other. I'm going to add those together, set it equal to 180. So you should have had x plus 18 plus 2x equals 180. Okay, to get x is equal to 54. Once you solve for x, you want to substitute it in for angle W. So you have 54 plus 18. And you should have had 72 degrees for the measure of angle W. Okay, for number 8, angle X, that one does not have the variable x in it, so you shouldn't have plugged in 54 for y. Okay, y is a different variable. So again, you need these opposite angles. Okay, those opposite angles are supplementary, so you should have added them together. So 3y minus 7 plus 3y plus 1. Set that equal to 180. To solve for y, which was 31. Okay, then for angle x, substitute 31 in for y here. So we have 3 times 31 minus 7. Get the measure of angle x is 86. Okay, so again, with these problems and your four-sided figure, your quadrilateral, you need to find the opposite angles. Do not set them equal to each other. Add them together, set it equal to 180. Okay, so add together equals 180. They are not equal to each other. A very common mistake. Okay, last question on here is a writing question. So it wants you to compare and contrast inscribed angles and central angles of a circle. If they intercept the same arc, how are they related? I want you to discuss that with the people in your group. Okay, so talk about the difference between your central angle and your inscribed angle. Talk to each other.
How did you get 54?
How did I get 54? I had 3x plus 18 equals 180. Subtract 18 and then divide by 3. Because this is not a diameter. So it's not, this arc is not 180. No, I know, but the intercepted arc isn't 180, so it wouldn't be 90. So these two are getting equal. That means all right, so for this writing problem, okay, your differences, your inscribed angle has its vertex on the circle. Okay, so your vertex has to be a point on that edge or a part of your circle. Your central angle has a vertex at the center. So think central is center. Your vertex is from the center of the circle. Now that second part said if they intercept the same arc, how are they related? Well, if you look back to the front of your note sheet here, where I drew in a central angle and an inscribed angle, okay, the inscribed angle and the central angle intercepted this arc DF. Well, your inscribed angle would be half of your central angle. So that's all you would have to write for that second part there. So if an inscribed angle and the central angle intercept the same arc, so I'm just taking it from what the question is stating, then the measure of the inscribed angle is going to be 1/2 the measure of the central angle. Okay, so you could have also said the opposite. You could have said the central angle will be double the inscribed angle. Okay, so that's if they intercept that same arc. You do need to know the difference between the central angle and inscribed angle for your assignment. Okay, there are problems that are matching, so you have to draw lines to match on those last 2 pages of your assignment. So those ones are matching. Oh no, the second page is just matching. So you need to know the difference between your central angle and your inscribed angle. For that first section there, numbers 1 through 5, those are central angles, okay? So use that as central angles the same as its intercepted arc. For that second section, 6 through 10, those ones are not central angles. Those are inscribed angles. So use that you take the angle, double it to get your arc. That last section on the bottom of the second page, you have a combination of central angles and inscribed angles. So you have to think about the differences there. And yes, I know there is a blank space. You have to find that one and which one it matches to. On the last page then, you're just finding all of those measures using the circle provided. Okay, so make sure you are working on this. Central angles and inscribed angles are a little bit more challenging. That's why I gave you a little bit more challenging problems, so you understand the difference between the two measures, okay? Because I really need you to understand that difference.